this new video where we are going to go through the count special triplet. So a special triplet has been defined as follow. So we should have three indexes where the index in the middle times 2 should be equal to the index before and the index after. So this is the definition of it. One example is this. This is a perfect example of a valid triplet. And why? Because the element at index 1 is equal to the element at index 0 times is equal to the element at index 1 times 2, which actually make this one valid, and the element at index 2 is equal to the element at index 1 times 2, that also make this one valid. So this is actually one valid triplet. Now the question is, given an array, how many valid triplets can we have in the array? We count the special triplet here, but you can call it whatever you want. So the answer is, the question here is, how many of them can you find in the array? To ease the process of solving this, we can just put it this way. For each of the elements that we see, the question is, how many double of me do we have before me, and how many double of me do we have after me? And if you are able to answer that for each of the elements that you are working through, then you are able to solve the problem. What do I mean by that? Let me say I'm taking this array for instance. If I'm here, the question is, how many elements that are my double that are before me? There is none of them, right? So this one will give you an answer of 0. Now for this one, how many elements that I have before me that are my double? None of it. So there is actually 0, no matter what we have in the right side, because it will be 0 times that element. Now taking 2, this one, how many elements do I have before me that are actually my double? I have 1, right? How many elements do I have after me that are actually my double? I have 2. So it's going to be 1 times 2, right? Which is actually a 2. Now when I'm taking this one, how many elements do I have? You see the key before me, 0. So this one will give you 0. If I try with this one, how many elements do I have before me that are actually my double? This one will also give me 0. This one will give me 1. Why? Because how many elements do I have before me that are actually my double is actually 1. After me is actually 1. And this one is 0. And this one will give you a final answer of 3, because we have 2 here and 1 here. So given this description, we can think of having a map that is going to count the occurrence of each of the elements, right? If you have the count of each of the elements and then you fill that into the next initially, and while you are moving, you remove the element to the next and then you put to the previous. In that sense, at each position you'll be able to know, okay, at each position you'll be able to count the number of occurrence of each of the elements before and after a given position. If you are able to do that, then we are able to solve the problem. So let us take a look at a solution that I came up with. My solution look like this. I will have like a map of int long. I'll explain you why I choose to go with long instead of int here to count the number of occurrences, which is actually the previous and the next. And then I fill everything into the next, because when I'm starting, everything is actually into the next. Now I have my second loop here, which is actually useful for me to loop through the element to count each of the occurrences. And whenever I'm in a current element, that element is no more in the next, right? So if I'm here, this element should not be considered into the next element. So whenever I'm choosing an element to compute, I'm removing that element into the next, I compute, and after the computation, I add it to the previous. So when I'm here, this one is actually the current. It should be get out in the list of the next. I do what I have to do, then I put this into the previous and I move to this one, and so on and so on. Now, given that this number can be really large, this multiplication can easily find itself out of range of what int can support. That's why I decided to go with long. In that sense, this multiplication now can be valid, but I'm making sure that the answer that I'm using is actually mod what has been set here. And I decided to put the mod here at the end, but you can also put it here if you want. You can wrap it here and put the mod here, but you got the idea. The long is just for me to avoid having answer which is out of what int can support. So you don't even need this extra parenthesis here. Let us submit and see what it gives. We can see that it's working perfectly. Now that this has been done, you can see that the performance is not that great. One little thing that you can do that will optimize the performance is just change the map into another map, because when you use a map, you try to keep it sorted, right? If you just change this into another map, it's going to leave the array as it is without sorting it, which is perfectly what we want. We don't really want it to be sorted. So let us submit this and see how it's going to improve the performance. We can see that we were able to move from 10 till beating 62% of C++ solution. So this was my solution on this. I'll be happy to see how you approach this and how you solve it. Feel free to leave me a comment. See you. Ciao.